Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so week number 14, week number 14. So this is the last formal lecture lah, because we replaced yesterday slot. Okay, so kita nak go through beam analysis using moment distribution method. So under beam analysis, as I mentioned in my previous video about beam analysis using moment distribution method, we cover beam. Okay, beam analysis with subjected to loading, and another one is beam with the effect of support settlement. So in last week video, I have actually explained a bit about the concept of support settlement in beam, and then video this afternoon. Okay, I have actually explained about the concept as well as the example. I have explained example given in the slide. Okay, so kita akan go through example yang ada dalam textbook. Okay, if you have question, you can switch on your microphone and ask question. Okay, so this one we have actually discussed last week. So three span beam or three members. So always remember, in moment distribution method, we are calculating internal moment or member end moment or bending moment. Okay, that is why the value that we get from the table, we can use it to draw the bending moment diagram. The first and the last value, okay, for each member. Okay, so that is the basic lah. So after that, actually we can continue to calculate the vertical reaction at each support, and after that we can draw shear force diagram and bending moment diagram. If we just need to draw the bending moment diagram, actually we can draw directly by using the value that we get from the table. But if we want to have the salient point, for example, the maximum moment in the bending moment diagram, of course we have to have the shear force diagram. So we have to analyze the vertical reaction at the support and then draw shear force diagram, then only we can get the maximum moment in the bending moment diagram. Okay, so step there. Okay, number one, of course, we have to calculate the stiffness factor K. We have to identify or calculate stiffness for each element. For example, if we have three members like this, A, B, B, C, and C, D, so we will have 3K. One for AB, one for BC, and one for CD. That is member stiffness. So from the member stiffness, we will continue to calculate distribution factor. Distribution factor is member stiffness divided by joint stiffness. Member stiffness divided by joint stiffness, and distribution factor equal to 1 for each joint except fixed end. And fixed like A and D. Okay, and fixed like A and D. Okay, the distribution factor equal to 0. Distribution factor equal to 0 for far and fixed. And fixed refers to A, refers to D, because B and C need internal support. And internal support, we have to assume internal support as fixed end. Okay, so total DF, so DF for B is 1, DF for C is 1. Okay, and then B ni is combination of BA and BC. B is combination of BA and BC. Same goes to C. C to combination of CB and CD. So number of member and moment in this case, so we have 6. We have 6, so we also have 6 distribution factor. 6 distribution factor. Okay, so this is the basic question without support settlement. So we calculate FEM due to external loading only, and I have explained about FEM. Okay, quite detailed. FEM is actually behavior. Okay, behavior FEM ni. Okay, so always remember sign convention that we use in this topic. Sign convention for MDM, we assume that clockwise is positive. Clockwise positive. Clockwise positive. So for FEM we will get 1 negative, 1 positive because of the behavior. So detail dia dah ada dalam previous video. Okay. And then this fixed end moment we substitute into the table. We substitute into the table. So we have 4 joint A, B, C, and D. A, B, C, and D. So we have 6. We have 6 end moment. 6 end moment because one member has 2 end and there are 3 elements, 3 members. So AB, 1 member, 2 has 2 end. So that is why we get total 6. Okay, 6 members, 6 distribution factor as well. So DFAB equal to 0. DFDC equal to 0 because N fixed and for N condition, for N fixed. And total DF at B is 1, DF at C is 1, total BA plus BC equivalent to 1, CB plus CD equivalent to 1. Okay, so calculation dia macam kat atas ni lah, quite simple, quite straightforward. Okay, then we will put the first member and moment in the table. And the first member and moment in the table we get from fixed and moment. And fixed and moment ni there are 2 types. One is due to external loading, another one is due to delta. So in beam normally the delta refers to support settlement in beam. In frame normally the delta refers to side sway. Of course we can have support settlement in frame, but normally support settlement in frame occurs when we have to analyze, when we need to analyze frame, properly restrained frame. So in that case we may have delta due to support settlement, but normally frame, delta in frame we focus on side sway frame. Okay, covers by other lecturers, Dr. Hazrina and Dr. Tevin. Okay, so fixed end moment is the first member and moment in the table. The first member and moment in the table, 1 negative, 1 positive. For member BC is due to the behavior because moment acting like this. Okay, due to bend beam 2 after okay, due to loading, the beam will bend. So due to bend beam, we have to apply moment to counter back, to push back the beam to its original position. Okay, the moment, the fixed end moment, okay, we apply at both end, and in this case B and C, we apply in this direction to push back point B and point C, so that the beam will move back to its original position. That is why direction to like this. Okay, and then when we compare with sign convention, we get negative and positive. So this negative and positive we put at BC and CB. So we get negative 240 and 240. Okay, we use formula given, normally formula given in the question. Okay, so same goes to member CD. Member CD subject to point or subjected to point load. Point load at the center. We use formula. The most important thing is the sign. Okay, again it is negative, positive, negative and positive, because of the behavior. And FEM is the first member and moment in the table. So after we put all the fixed end moment, the member end moment, the first member end moment, we need to do the first distribution. We need to do the first distribution. So we have to distribute moment. We have to distribute moment. So the moment, how to distribute the moment? We have to distribute joint moment. We have to distribute joint moment. Means that at B, so this is joint B. This is joint B. So we get two. Okay, this is B. So this is B from A. This is B from C. Okay, so it is negative 240 kat sini. Negative 240. Negative 240. Kat sini 0 lah because AB ni kan. Sini AB no FEM. No FEM for AB. BC we get FEM negative 240 and 240. And the moment that we distribute is joint moment. And joint moment is opposite with member and moment. Okay, so yang ni yang kita distribute. That is why kalau you recall back to what you have learned previously, masa diploma, normally masa peringkat diploma tu kita tak faham sangat the process, tapi kita follow je the procedure. So okay, that is why selalu macam tu kan. Masa saya belajar dulu pun sama. Okay, bila saya belajar first MDM ni kan, memang hafal step ni. Okay, it is sini 0 kan? Sini 0. So 0 plus negative 240. 0 plus negative 240 times 0.5. Change sign baru letak value tu kat sini. 120. But the actual process is we distribute joint moment. Joint moment at B. And joint moment at B is positive 240. Joint moment at B is positive 240. So this 240 yang kita distribute. Okay, 240. We distribute 240 joint moment which is opposite with member and moment. So 240 yang kita distribute, yang kita kali dengan 0.5. So that is why we get 120. Okay, 120. So same goes to C tu, C. Where from CB we get 240, from CD we get negative 250. So joint moment at C. Joint moment at C, if we try to draw the diagram, so kat sini C. So we get moment dekat sini ada BC, right? Sini BC, sini CD. And fixed end moment, the first member and moment in the table. The first member and moment in the table. Okay, yang ni we get 240. Yang ni we get 250. This is the value that we put in the table. Okay. And the moment that we distribute is joint moment. So joint moment opposite dengan member and moment. So joint moment, this, opposite. So this one is 250. This one is 240. So yang ni yang kita distribute. So that is why the value, the total moment that we distribute is 10. The total moment that we distribute is 10. Okay, 10 times 0.4 we get 4. 10 times 0.4 we get 4. 10 times 6, 10 times 0.6 we get 6. Okay, joint moment. Okay, so then after that we have to distribute. We have to carry the value. Carry the value by times with the factor. And the factor we have to consider n condition. Since A and D tu both are fixed and far and fixed, internal fixed. That is why all value we divide by 2. All value we divide by 2. It is actually like this. All value we divide by 2, we get 60, 2, 60, and 3. And after that we have to repeat the process again. Repeat the process again macam tadi. Okay, macam tadi ni, it is negative 2 times 0.5. That is why we get 1. Because joint moment is negative 2. Joint moment is negative 2. Same goes to this. Joint moment is negative 60. Negative 60, so we time with the factor, so we get negative 24 and 36. And then repeat again, divide by 2, carry over factor is 0.5. Repeat the process until the moment reaches 0 value. Until the moment reaches 0 value, stop at distribution. Stop at distribution. You cannot stop at carryover, because if you stop at carryover, you will get unbalanced moment. Okay, the total moment tu. Okay, stop at the level distribution. Okay, whenever the moment reaches 0 value. Basically, 5 times, 6 times. Like that only. For 3 span. If we analyze 2 span only, okay, the process will be very short. 1 or 2 cycle dah finish. There's no moment to distribute anymore. If we have 3 span like this, basically we need to have a 5 or 6 cycle. And then we will meet 0.0 something and we can stop. Okay, stop at level distribution and then total all the moment in the table. The first moment in the table, remember, the first moment in the table is fixed end moment. So start from fixed end moment, total all the value, and we get 6 end moment. 6 end moment. So from this actually we can sketch the bending moment diagram, because we have already know the first and the last moment for each element, for each members. Okay. So this is example 12.1. Example 12.1 yang ni pun dah discuss last week. Okay. Okay, if you refer to the latest version of textbook yang memang buku punya tu, so semua unit dia unit SI. But the e-book that I have ni, okay, I'm not sure, this is 9th edition kot. Okay, dia ada combination lah, combination SI and Imperial unit. Doesn't matter, kita just nak follow the procedure, nak tengok how we solve, okay, this. Tak kisahlah whatever unit, kita just nak tengok numbering kan. Okay, so yang ni example, one example, beam yang end dia end cantilever. This is end cantilever. End cantilever. So if you okay, if you have question, okay, refers to past exam question, if you have to solve, okay, beam with end cantilever, you want to solve using moment distribution method, so you can refer to this example. So what's the difference? The difference is AB ni, because end cantilever means A has no moment. A has no moment. A has no moment, so we only have a moment MBA, FEM to FEM, the first moment. The first moment in the table is MBA. MBA that we get from P times L for AB. And for the stiffness factor, we only calculate full BC and CD. For N cantilever, we don't need to calculate K. So the process is equal except distribution factor at BC ni, yang ni special sikit. Because when we analyze this, always remember that D ni distribution factor of D, because N fixed must equal to 0. Distribution factor at C, yang ni DF is equal to 1 total. CB plus CD. At B, again, distribution factor must also 1, equal to 1. Combination of BA and BC. But in this case, since BA tu, kat sini special if we have cantilever N. Okay, if we have cantilever N, we have to consider this. Okay, distribution factor for BC equal to 1 minus DFBA, like this. Okay, this is special for N cantilever. Okay, and special for N cantilever. So we get the first member and moment value for member for BA. For BA we get from P times L, ni P, ni P, ni L. We get this, and FEM for member BC, CB we calculate as usual. So we put this into the table. Yang ni jarang-jarang lah keluar dalam final assessment, tapi if you need to analyze N cantilever, this is how we analyze N cantilever beam. Okay, so this is BA. This is BA. So we only have three joint in the table, B, C, and D. B, C, and D. So yang ni yang tadi yang special tu. Okay, yang lain sama. Okay, yang lain sama. So we get like this. Okay, yang ni saya tak go in depth. Okay, if you have to refer to N cantilever example, please refer to this example 12.2. Okay. Okay, we move to the next example. Okay, this is example to spend only. To spend only. A is fixed. C is roller. C is roller. C is roller. So this for the distribution factor. For distribution factor at A, because it is fixed and this is equal to 0. Distribution factor at C, because this is N roller, distribution factor is equal to 1. Distribution factor for B also equal to 1, but B consists of BA and BC. Total BA plus BC equal to 1. So two members only means that we only have two value of stiffness factor for two members, and then we will get distribution factor for value for distribution factor, because we have two members, so each member has 2n, so we have 4. It is 0. Okay, total this equal to 1. And then fixed end moment, fixed end moment. Okay, video petang tadi saya tunjuk alternative solution. Whenever we want to analyze example like this, which far end is roller, far end is roller or far end is spin, but we still want to use formula of FEM assuming both end fixed. Assuming both end fixed. Yang tu another alternative. So yang ni memang dia terus pakai formula considering N roller, WL square over 8. So we get FEMBC only. FEMCB equal to 0. FEMCB equal to 0. So that is why in the table we only have one cycle, and after that there's no moment to distribute. Okay, so FEM we get one only for BC. For BC, so this 12,000, the joint moment is this one is negative, joint moment is positive. Joint moment is positive. That is why we get 5647.2 and 6352.8 all positive, so that when we total this and this four value, we total, we get 0. So we have to we have to carry over, but for N roller, the factor, the carryover factor is equal to 0. That's why here it is just that we don't carry the value. But for N fixed A, A is fixed n, so the factor is 0.5. The factor is 0.5. That is why 5647.2 we divide by 2. So we get 2823.6. Okay. So we total the moment. So we get like this. And dua-dua ni, okay, we get 0. Total is equal to 0 because MBA plus MBC is equal to 0. So this concept MBA plus MBC ni, you can find the theory, okay, of this under topic slope deflection equation. Under slope deflection equation, we will understand why these two value, okay, will always like this. Same value, opposite condition. One negative, one positive. And from this value, we can actually identify the position of the moment in the bending moment diagram. Okay, basically saya buat macam ni je. Okay, for AB, the moment is clockwise. Okay, for BA, moment is clockwise. BC, moment is negative, counterclockwise, and then 0. So when we draw the diagram, the bending moment diagram, okay, for member AB, one negative, one positive. Okay, both positive, both clockwise. So, okay. So we just need to draw the moment direction. So clockwise is going to be like this. Clockwise is going to be like this. Okay, clockwise. So means that the position is here and here. Okay, so we get this as the bending moment diagram for member AB. For member AB, clockwise. Okay, and then we have for member BC. For member BC, we have here B and C. Moment is counterclockwise. Moment is counterclockwise. The moment is counterclockwise. And the last value is 0. So this is the point. Okay. And then UDL, right? UDL means, okay, we may have like this. Okay, we get this. We will confirm this has maximum moment from shear force diagram. Ni yang ni kita just assume. If we have trapezium yang ni kalau shear force diagram dia ada intersection then only we have the maximum moment. The maximum moment. This is shear force diagram. So the maximum moment, okay, the maximum moment we can get from shear force diagram. When the shear force diagram has intersection, then we have maximum moment. If shear force diagram, for example, if shear force diagram we get trapezium. If shear force diagram we get trapezium, maybe trapezium like this. Trapezium, this is also shear force diagram. Shear force diagram. If we get trapezium, so what happened to the bending moment diagram? Sinilah. Okay. Point dia kat sini. Last point dekat sini. Okay. So we don't have maximum moment. Maybe macam ni je. Curve. Okay, we don't have maximum moment. So in detail, if we want to have the detail shape, the accurate shape of bending moment diagram, yang tu you have to write the equation lah. Get equation, write moment equation, substitute add value, you pakai small interval, then you will get the right shape of bending moment diagram. But basically, if we have yang ni if we have intersection in the shear force diagram, so we will have maximum moment in bending moment diagram. If we have trapezium for shear force diagram, we don't have maximum moment in the bending moment diagram. Basically like this. Okay, so this is the diagram. When we combine, this is the diagram. Okay. Okay, example 2 je. Okay, doesn't matter. I want to relook to the example in slope deflection method. Okay, both method sama same output tapi different procedure, but the concept of beam and frame banyak dah discuss dalam this chapter. Okay, for example, joint moment tadi MBA plus MBC equivalent to 0, semua dah cerita dekat sini. How are we going to identify whether the frame has side sway or not? So pun dah discuss dalam this topic, chapter number 11 in the textbook. Okay, I want to pick one beam question in this topic, and we will try to solve it using moment distribution method. Okay, this is the concept of joint moment. Joint moment ni dia opposite with member and moment, because member and moment assumption that we made at the beginning of the process. So clockwise moment that act on the member is moment that act on the member is considered positive. Clockwise moment act on member. So this is joint, counterclockwise. So counterclockwise ni lah, counterclockwise. Okay. This one settlement beam with settlement at B tapi tak ada loading pula. Tak apa, doesn't matter. Tengok example lain. Push downward, internal moment. Determine internal moment at support, at the support of the beam. Roller support is pushed downward 0.1 feet by force P. Tak banyak example Okay, tak apalah, kita tengok past year's exam, past year's paper. Yang ni yang saya ada ni 521. Tak apalah, 521 So sama je. Actually in Penang, the code for indeterminate structures is CS521. Sama je. Okay, topik tu sama. Okay, yang ni okay, boleh juga nak buat this one. Tapi kat sini ada external moment, so dia ada additional sikit lah. Dia ada additional sikit nanti in the table analysis. How we are going to include this joint moment 1 to 5 kilonewton in the table. Okay, yang ni pun boleh buat. Okay, we have A, B, C, and D. We have A, B, C, and D. This is a continuous beam. A is fixed. B, C, and D pin. EI, EI2, EI, EI, EI2, EI. So this is 125, 150. Okay, I add additional support settlement. So detail support settlement, please refer to the other video this afternoon I made. Okay, ada dua link saya bagi tadi kan, dua link. One is live event link, one is this link. So live event link tu boleh use the same link to watch the recording. Tapi lepas ni saya akan upload both lah. Saya akan upload this link, this recording and yang live event recording lah, both in my YouTube channel. Okay, so this is the question that we are going to analyze together malam ni before we end the session. Okay, so I want to add support settlement. Support settlement. So let's say we have settlement occur at C. Settlement occur at C. Settlement occur at C 30 mm. 30 mm. So saya nak terus buat guna Excel because MDM ni is very popular, famous topic in the world. So bukan hanya masa belajar ni je important. So nanti as engineer, you will need this also whenever you want to design. I do analysis and design structures. Okay, you may use this MDM in order to draw the bending moment diagram very fast, bending moment diagram, because from the bending moment diagram, we can identify where is the crack in the structure. Okay, so let's say in this beam, I add additional support settlement. So beside loading in the diagram, I have add support settlement at support C 30 mm. 30 mm. Okay, video petang tadi, tengah hari tadi, video tadi ada example tu is based on the exercise given in the slide. Yang tu ada two settlement occur. Settlement occur at two positions. So now I want to focus on how to analyze this beam using moment distribution method. We analyze FEM due to external loading plus support settlement that is occur at one position, which is at position C. So as I mentioned, FEM for so in beam analysis, we can combine FEM because we can calculate FEM due to external loading using formula, because the loading PW we know from the question, and also the support settlement, because support settlement is always given in the question. The value of settlement is always given in the question. So we can also calculate FEM due to settlement due to delta directly. So we can have FEM due to external loading, and we have FEM due to settlement. Okay, then we can combine FEM. So we just plus FEM due to external loading plus FEM due to delta. We put into the table the total FEM, then we can distribute moment, and we can have the internal moment or the output by using one table only. But we cannot do that in frame, We cannot do that in frame because frame with side sway, we must have two tables. We cannot analyze frame with side sway with one table, because side sway, the delta in frame, the delta is unknown. In frame, the delta is unknown. So when the delta is unknown, we cannot add directly like beam. We cannot do that. So if you want to watch my lecture on frame, you can refer to my YouTube channel. Okay, if you want to refer to frame analysis. Okay, so frame for you saya tak cover lah, saya tak cover dalam 14 minggu ni. Saya tak cover sebab cover by Dr. Tevon and Dr. Hazrina. Okay, so yang ni Yang ni kita nak terus buat in Excel in Excel. So saya open Excel. Okay. Okay, we will have one table. We have three span. Okay, the table must have a number of join A, join B, join C, join D. Nampak tak? Okay, join and then member. Member ni refers to member N. So we have AB, we have BA, we have BC, CB, CD, and DC. So join, we have join A. Okay, this one is join B. This one is join C. This one is join D. So 4 join. And then I will calculate K in the table as well. So K, it is K member stiffness in terms of EI. In terms of EI, so that I can put all the value here. So for AB, it is, okay, for AB, we use 4 EI over L because NA is N fixed for N fixed. It is 4 divided by 2.8. Divided by 2.8. For AB, BA is the same. One member, cuma dia one, we have AB and BA because of member N. So dua-dua ni the same member, the same element. Okay, so yang ni, it is 3 meter, it is 4 divided by 3. 4 EI over L, so 4 EI over L, so 4 divided by 3. So this is 4 divided by 3. And for member CD, we refer to far N. Far N is D. Far N is D. D is pin. So D is pin. So we use 3 EI over L. 3 EI over L. And don't forget to include 2 EI. Don't forget to include 2 EI here. Sini ada 2 EI. Don't forget to include. It is 3 times 2 lah. 3 times 2. Divide by 3. 3 times 2. 3 times 2 divided by 3. Berapa? 2. Okay, 2. Three times 2 divided by 4 EI over L. Betul eh? Okay, so yang ni. Okay, I will set up to 3 decimal places. Macam ni. Okay, so lepas K, distribution factor. Distribution factor for N fixed. N fixed is 0. N fixed is 0. N pin is 1. Okay, and fixed is 0 and pin is 1. So yang lain calculate lah. So this one divide by total K. Total K means yang ni total dia. So this will be the total. This is total K. Lagi senang saya buat macam ni lah. Okay, this is total K. Okay, total K means K at join. K at join means this. Total K means yang ni plus total K. This is total K. Okay. Total K at C, total K at C is 1.333 plus 2. Okay. So distribution factor, for BA. BA means it is member stiffness divided by joint stiffness is 0.517. Member stiffness divided by joint stiffness. Okay. Total distribution factor for CB, member stiffness divided by joint stiffness. Member stiffness divided by joint stiffness. Okay, I set up to 3 decimal places. Okay, this is distribution factor. Okay, distribution factor. Okay, distribution factor. Okay, now we will calculate FEM. FEM number 1. FEM1 due to external loading. FEM1 due to external loading. Okay, due to external loading, FEM ni is just like beam. Sorry. It's just like stiffness method. When we analyze beam with stiffness method, we use fixed end moment formula to distribute moment. So same goes to this. So joint moment ni tak masuklah dalam FEM. Okay, joint moment tak masuk dalam FEM, but dia masuk dalam distribution later on. Tapi for fixed end moment, kita hanya consider 150. This 150. Okay, 150, it is WL squared over 12 for member CD. WL squared for member CD. It is 150. It is negative, 150 times WL. L is 3. Times 3. WL squared over 12. Okay, another one is positive. Okay. So if actually you have to refer to the question because sometimes B macam ni, sometimes kan soalan dia soalan A calculate end moment for the beam shown in the figure. Question A. Question B. If B is settled, so B tu dia ada B to settle support settlement tu comes as additional question. So yang macam tu we can analyze end moment ni using 2 table. Means that kita dah buat one table considering external loading only and then baru datang delta tu as additional question. So we just continue to calculate FEM due to delta in another table and then we combine the table. Yang tu boleh solve guna dua table. Tapi kalau dalam soalan tu dia dah combine siap-siap. Then we can combine FEM as well. Okay, saya tunjuk yang kaedah yang pecah dua table. One is for external loading and another one for support settlement. Yang combine dah tunjuk dalam video petang tadi . Okay, so yang ni So FEM1 for external loading. So then we start with distribution. Distribution number 1. So total moment at joint C. Total moment at joint C. Okay, total moment at joint C. Okay, tengok pada diagram. Just look at the diagram. At B ada joint moment. And this joint moment, we have to distribute in the table. Okay, we don't have FEM for AB and BC, but we have joint moment and applied moment that is subjected directly at joint B, and always remember that the moment that we distribute is joint moment. So that is why under distribution we have to distribute this moment. Under distribution we have to distribute this moment. So tak kisahlah you nak letak dalam table tu macam mana, tapi you have to distribute the moment. You have to distribute the moment. Okay, so how to do that? How to do that? We have to distribute. Okay, you can have joint moment kat sini if you want. Joint moment. And joint moment, that is why the understanding of the concept is very, very important. Yang ni joint moment clockwise. Clockwise is 1, 2, 5. So this is 1, 2, 5. Okay, this is 1, 2, 5. 1, 2, 5, it is clockwise. It is clockwise. So for distribution, first distribution yang ni, we have to have 1 to 5 joint moment times with factor, distribution factor. Joint moment, so tak payah change sign lah, joint moment kan. Joint moment times with factor. Okay, and then joint moment for C, joint moment for C, we get from 0 plus negative 112.5, joint moment tu 112.5. Joint moment tu. Tak kat sini lah joint moment. Yang ni step yang ni, line tu you boleh skip kalau tak ada joint moment dalam soalan ya. Tak ada joint moment yang just like this in the question. Okay, joint moment. Zero plus with joint moment is 112.5. Joint moment. Okay, so yang ni we want to distribute joint moment, means this one times with factor. (45) and times with factor. Okay, so I use second alternative to solve this by assuming that both n is fixed even though the n is pin. So by assuming both n fixed, so saya pakai formula both n fixed, that is why WS squared over 12. So I have to put the value here, and what I need to do now is I need to take this and times with the factor 1. Times with the factor 1, so what I get is negative 112.5. So total ni dah dapat 0. So dapat 0 ni representing roller and pin n, where the total moment where the moment at n pin is equal to 0. Okay, so then only we carry over. I want to set the decimal places. Okay, up to 3, like this. Okay, continue with carry over. Remember the factor, we have n pin here. We have n pin at nd, n pin at nd. Okay, the rest we divide by 2. We divide by 2. Okay, cross boundary. Cross boundary. This one. This one. Okay, cross boundary. Okay, so we get here is 60 divided by 2. 45 divided by 2. Negative 112.5 divided by 2. Except 67.5. Except 67.5 because the factor is 0. This one is 0. Okay, this one is 0. Yang ni. This one is 0. Okay, because the factor is 0 for n pin. N pin N yang paling hujung N pin. Internal semua assume fix. That's why internal semua we divide by 0.5. We divide by 0.5. Okay, then repeat the process. Distribution. Repeat the process. Okay, repeat the process. So it is negative. Okay, this one plus total moment. Total moment. I put negative because I don't want to repeat join moment at one row. Okay, yang ni times with factor 0.517. 517 is total moment times with factor, distribution factor. Okay, so total these four value, the total must equal to 0. Okay, move to join C. Move to join C. 30.172 plus with 56.25, negative 56.25 times with factor 0.4. Okay, 30 ni, 30 plus 30 ni plus times with factor 0.6. Okay, and then there's no moment for column DC. So we only have this value when we distribute moment. Okay, carry over, carry over, carry over, again carry over, carry over, carry over. Okay, boundary. Sini boundary lah, boundary between A and B, boundary between B and C ni boundary dia. Boundary. Boundary between C and D. Ada boundary, 3 boundary. So when we carry over, we cross the boundary. When we carry over, we cross the boundary. Okay, so we divide by 2. By 2, we cross. When we carry over, we cross boundary. But this one equal to 0. Okay, because there is no value to distribute. Moment, we cannot distribute moment to pin N. We cannot distribute moment to pin N. The carryover factor, the factor is 0. So it is just 0 like this. Okay, repeat again distribution. Repeat distribution. Again, repeat the process. It is 0 plus 5.21. Okay, 0 plus 5.21. Opposite, it is negative 5.21. That is why I put negative here. It is 0 plus 5.21 times with factor 0.517. 0.517. I get this. Negative. It is 0 plus times with factor 0.483. Okay, this total, this 4 total must equal to 0. Okay, negative. Okay, it is negative. I put negative to represent opposite condition. Okay, join moment opposite with member and moment. So I put negative. So this one plus 0 times with factor is 0.4. Okay, we just need to repeat the process again and again until the last distribution reaches 0 value. 0.6. 0.6. Okay. Okay. So carry over, distribution, carry over, distribution, carry over, distribution. Okay, 1, 2, 3, 4, 5, 6. 5 or 6 distribution will be enough. Okay, last one, last step must be distribution. Okay, and this is end moment. This is end moment or M1 lah. This is M1. M1 tadi refers to external loading only. External loading only. Okay, so we want to sum the moment. Okay, to get the total moment. To get the total moment, start from the first member and moment in the table. Start from the first member and moment in the table. So kita tengok sini ya. So yang ni kita akan sum all this. So we get all this. So this is the moment. Okay, yang ni start from, because yang ni join moment kita tak tambah Kita tak tambah. So kita start dengan 64 ni. 64. We get 49.6. 49.6. Yang ni Total moment is 75.4. Okay. So yang ni total moment is 81.395 3 decimal places. Okay. Yang ni total moment dia plus with moment yang ke atas tadi tu. Yang ni. Because yang tu FEM. So the value will be the same but opposite direction. Yang ni. Same but opposite. Okay, yang ni total dua-dua ni we get 0. You get 0 lah. So this, okay, this value is the end, not the end moment. Yes, the member end moment. This is member end moment. This is member end moment. Member end moment for table number 1. Member end moment for table number 1 considering external loading only. Okay, kalau soalan tu tak ada support settlement, so this is the answer lah, this is the answer. So sini saya highlightkan blue because kalau tadi as I mentioned, total MBA plus MBC equal to 0, yang tu because tak ada external loading, tak ada external moment. Macam yang ni lah, 81.396 and negative 81.396 because at C, moment at C is equal to 0 because it is pin. But at B, even though dia pin, tapi dia ada kat sini applied moment 125. So the total that we should get from MBA plus MBC, total ni mesti dapat balik 125. 125 because of the joint moment or an applied moment that is subjected at joint B. So total ni lah, total ni. One to five. It is 1 to 5. Dapatlah 1 to 5. So this is the end moment for table number 1. Table number 1. Okay, now I want to move to table number 2 considering support settlement. Considering support settlement, so yang ni saya copy balik. I want to have DF only. So we move to the second part of analysis. Second part of analysis, distribution factor. Okay. Distribution factor. Now we will calculate FEM. FEM number 2. FEM number 2 is for support settlement. Support settlement. Okay, so support settlement at C. There is 30 mm. Okay, settlement at C, which magnitude of 30 mm. So if we want to understand the behavior of the beam after settlement. After settlement, we just need to sketch. Okay, sketch lah, sketch. Sketch only, so this is C. So we have A, B, C, D. C settle. C settle means that A remain at same position, B remain at same position, C ada settlement 30 mm and D remain at same position. So 30 mm tu kat sini. 0.03. 30 mm. 30 mm. Okay, please refer back to video this afternoon where I have explained quite detail about the settlement. Okay, what most important is, okay, saya akan pakai formula considering assuming both end fixed, even though we can have another formula considering end condition for end pin, tapi saya nak tunjuk another alternative for solution so that we can only refers to the first column in the formula, because in the formula in the textbook the formula for FEM ada dua column. The first column is for end fix, the second column is for end pin or roller. So saya dah pakai yang the first column only, assuming all fixed end. Okay, assuming all fixed end. Okay, so assuming all fixed end, so the formula for FEM due to settlement is 6EI delta over L squared. 6EI delta over L squared. So what most important is we have to find the triangular. The triangular, for example, here we have two triangular. So the first one, the first triangular is for member BC. The first triangular is for member BC yang ni. This is the first triangular. Okay, the first triangular yang ni. Okay, this triangular perpendicular. Okay, the length of member BC, is 3 meter. That is the length. And delta is perpendicular. Delta is perpendicular dengan length. The delta is 0.03. Okay, the incline. Okay, the incline representing beam after settlement. Beam after settlement. So the new position of beam after settlement is, okay, yang ni, yang green line ni. Beam after settlement. And always remember that the fixed end moment, okay, will push the moment at both end. The moment at both end, it will push the beam to move back to its original position. Okay, look at the inclined beam after settlement. So fixed end moment, moment tu dia akan push both end. Push both ends so that the beam will move back to its original position. Dia dah jadi macam ni. So push back. So moment tu akan push back. Okay. So the moment will be like this. The moment, the fixed end moment. Fixed end moment. Fixed end moment. So in short, what we can conclude is, okay, the easiest way to identify the sign for fixed end moment due to delta, okay, is by looking at this triangular. Looking at this triangular, original is horizontal. This is original. This is original. And beam is always horizontal, original. So we mark the angle, which is called as chord rotation. We measure from original position to new position. Okay, this is called as chord rotation. The angle from original position, to new position after settlement. Okay, the angle. If the angle is clockwise, FEM is counterclockwise. Between the angle and FEM, it must be opposite. Between the angle, which is chord rotation, between chord rotation and FEM. If angle is clockwise, FEM anti-clockwise, counterclockwise. Chord rotation clockwise, we measure from original position to new position. If the angle is clockwise, FEM is opposite. FEM is counterclockwise. Counterclockwise. Yang ni lah. Counterclockwise. What is the formula? It is 6 EI. So FEM, if this is B and C, so FEM BC equal to FEM CB, it is equal to negative. Negative because of the behavior. Because FEM ni dia behavior. Behavior apa? Dia nak push both end to move back to its original position. Okay, so we put negative because of the behavior. Because if we put wrong direction, wrong moment direction, okay, for example, if we put positive, what happened? If we put positive, dia tak jadi horizontal, dia jadi vertical. Okay, what we want is horizontal. So to get horizontal, we have to apply FEM counterclockwise. And FEM counterclockwise is negative. So the formula is 6 EI delta, which is 0.03. This one is 0.03 divided by L squared. Okay, divided by L squared. Okay, so this value I want to put into the table, and we will calculate end moment. Okay, so FEM for BC and CB will be the same. Both are negative, BC and CB, and we have CD and DC. So FEM BC, FEM CB, so we get negative 6. Let's say EI is 50,000. 6 EI delta is 0.03 divided by 3 squared is 9. So we get negative 1,000. Negative 1,000. Okay, so for CD, so the new position after settlement is like this. Okay, so the moment we apply to counter back. To counter back means we will have moment like this. Fixed end moment, which is positive direction to represent the behavior of the beam. Okay, so it will be positive FEM, positive FEM, and since the length is equal, length is equal, but EI is 2. Okay, so it is positive 6. Okay, times 2, 6 EI, 6 EI times 50,000 times 0.03 divided by, okay, so this is the FEM. Kecil pula tadi 100 je kan, kita tukarlah, kita tukar 50,000 tu jadi 5,000. Okay, I want to change this to 5,000 only. Okay, so repeat the process. Distribution, first distribution, total moment is 0 plus negative 100. I put negative to represent opposite condition of joint moment times factor negative times factor. Okay, continue, negative 100 plus 200 times factor 0.4 times factor 0.6. Okay, and yang ni it is negative 200 times 1. So total ni dah dapat 0. Okay, carry over. Macam tadi ada boundary ya. Boundary dekat sini. Sini boundary. Okay, cross boundary. 51 divided by 2. Cross boundary, negative 40 divided by 2. Positive 48 divided by 2. Negative 200 divided by 2. This one is 0 because the carryover factor is 0. Okay. Okay. So, distribution. Repeat the process. Carry over. Okay, again, the process is joint moment. Joint moment, the moment is 0 and negative 20. So, joint moment is positive 20. So, that is why I put negative. So, that joint moment, I will get positive 20. Times with factor 0.517. 0.517. Okay. Repeat the same process. It is positive 20 times with factor 0.483. Okay, joint moment, put negative 24 plus negative 100 times factor 0.4. This factor 0.6. Three decimal places. Okay. Okay, now I want to copy. Until the last distribution reaches zero value, 5 or 6 times. One, two, three, four, 5, 6. So this is M. Sorry, this is distribution. This is M2. Okay, total all the moments. Start from the first member N moment in the table. Sum all. So this is the N moment due to support settlement only. Support settlement only. So total moment. Total moment. The total moment, I just okay, total moment is, ya. Oh, tak nampak. Sorry. Sorry. Okay. So we get all the table number 1, table number 2, table number 1, table number 2. So table number 1, we have calculated we have calculated N moment due to external loading only. Saya tak combine sebab ada join moment 1 to 5 tadi. Takut dia akan confuse kalau saya combine. That is why saya pecah macam ni. Okay. And then table number 2. Table number 2 is for support settlement only. So dah siap, we combine lah. We combine M1 plus M2. We combine M1 plus M2. It is this plus this. So we get this. So this is the final answer. Okay, this is the final answer. Okay, again, total ni will be equal to 125 because of joint moment. Boleh check lah. Because of joint moment. One to five. Okay, so this is the moment considering both external loading and support settlement at sea. And special sikit sebab ada joint moment. Kalau tak ada joint moment, dia quite straightforward. But if we have joint moment like this, okay, joint moment like this, so you have to consider joint moment when as the first moment distribution in the table. Okay, so this the member end moment for this beam. And if we want to continue to draw diagram, as I mentioned, diagram dah boleh draw directly. Okay, we can sketch the moment diagram, but we do not know the maximum moment until we draw the shear force diagram. Okay, so yang ni, if we want to sketch that, so it is positive, negative, positive, zero. So dah boleh sketch dia punya first point and last point for each member. So the first and last point macam ni lah. Okay. Okay, yang ni dua-dua dekat atas. Kita just follow the moment direction tu. Okay, yang ni the last one like this. Okay. And we have UDL. Again, if the shear force diagram has intersection, then we will get like this. If not, just it is just like this. Depending on the shear force diagram. The first and the last position kita dah dapat lah directly from the moment that we have calculated, okay, in the table. Dapat yang ni. Okay, so actually detail kat sini, dia ada detail dekat sini kalau kita draw diagram tu kan. So if you want to calculate in detail yang ada dekat sini in between ni, konsep dia again ada dalam shear force diagram. Ada dalam slope deflection method, chapter number 11. Dia ada konsep kat sini, dia yang ni. Because we draw yang ni, we draw this bending moment from the beam, from member AB. Member AB ni, this is A, this is B. So we have moment 51.985, 51.985 ni. Sini 51.985. And 103.966. So we have this is AY and BY1. So from this we have to apply static equilibrium. Okay, yang ni 2.8 meter tadi. Apply static equilibrium. It is just like we analyze simply supported beam. So we can get AY and BY value. AY and BY value. So dapat AY and BY value, we can have the shear force diagram for member AB. Okay, so if we want to get the shear value or the vertical reaction at for member BC, sama juga macam yang ni. So we just need to we just need to have okay, it is 21.034. It is positive. -21.064 and -3.389. So it is negative 3.389. Again, dekat sini we have here we call as BY2 and CY1. BY2 and CY1. So we apply static equilibrium for member BC. It is just like we analyze simply supported beam. We can get BY2 and CY1. Okay. And then combination of BY1 plus BY2 is actually the value of BY. So BY is BY1 plus BY2. That is the vertical reaction at B. Vertical reaction at B. Same goes to C. CY1 plus CY2 equal to CY. The vertical reaction at C. Okay. So kalau C dia lain sikit lah sebab C ada UDL kan. C ada UDL. C ada UDL kat sini. Moment we have positive 3.389, 3.389. This is 150. This is 3 meter. Okay, so we have, this will be CY2 dy. Okay, then analyzing member CD, we will have analyzing member CD, we get CY2 and dy, we get from static equilibrium, and then we can plot the shear force diagram for member CD to identify whether this shear force diagram, the shear force diagram has intersection or not. Kat sini. Actually, for member AB and BC tu tak draw shear force diagram pun tak apa because dia memang tak ada intersection pun. Okay. So, intersection ada pada UDL. Maximum moment ada pada UDL. So, that one you have to analyze. Member CD. Member CD. Yang ni lah. So, it is taking moment. It is just like we analyze beam. Analyze simply supported beam. Total moment. So sini C and D, total moment. Let's say take moment at D equal to 0. So we get CY2 first, right? So it is 3.389. 3.389. Okay, plus 3 CY2 minus 150 times 3 times 1.5 equal 0. So this we get CY2 equal to Get 150 times 3 times 1.5. We minus by 3.389. We divide by 3. We get CY is 223. 223.87 kilonewton. Okay, so it is just like we analyze simply supported beam. Okay, where CY2 plus DY minus 150 times 3 equal to 0. So we get DY equal to 450 minus 223.87. It is 226.13. Okay. So what do we get from this? CY is 223.87 and 226.13. So the shear force diagram for member CD has intersection. It has intersection like this. Intersection. So identify the distance. Identify the distance. Then the area from the area, we can get the moment. We can get the moment, the area. So how to get this distance? How to get the distance? How to get the distance? No idea. Okay, the distance. So we have here 150 in unit kilonewton per meter. Kilonewton per meter. And we have shear value in unit kilonewton. Kilonewton. What we want is the distance in unit meter. What we want is the distance in unit meter. So we have 150. We have 150 in unit kilonewton per meter. We divide by 223.89 in unit. Terbalik. Terbalik. Okay, so we just have to play with the unit. Yang ni kita tahu dia terbalik. Okay, it should be not this. Because it should be 223.89 kilonewton divided by 150 kilonewton per meter, so that we will get meter, right? Because we have to identify the distance. Without the distance, we cannot determine the area of the triangular in the shear force diagram. We have to have the distance. So how to get the distance? So if you don't remember the detailed process, so it is just as simple as this. We play with the unit. It is kilonewton divided by kilonewton per meter. It is 223.89 divided by 150. We get 1.49. Sini we get 1.49 meter. 1.49 meter. So we get this as 1.49. Okay, remaining. So it is 226.13 divided by 150. We get 1.51. Total is 3 meter. Then only we can identify the maximum moment. So dia ada maximum moment lah kat sini. Maximum moment. So the bending moment diagram, okay, if we need to highlight the salient point in the bending moment diagram, okay, it is 3.389. It is positive. This one, 3.389. We have to plus with the area. The area of the first triangular. It is 3.389. We have to plus with 0.5 times 2 to 3.89 times with 1.49. The value is 170. 170.19. 187. 187. 187. We minus with 0.5 times 1.51 times 226. 226.13. Okay, so we get 0. So maximum moment is 170.187. Okay, this is how we identify the maximum moment, okay, occur at member B, member CD because of the UDL, Okay, so normally, so when we analyze beam using moment distribution method, especially for design purpose, memang kita nakkan the moment diagram tu. Okay, moment diagram. So that is why even though the outcome for moment distribution method is internal moment or member end moment, the value that we get from the table, we can draw the bending moment diagram directly. But, okay, to get the salient point, the maximum moment in the bending moment diagram, so if we look at this beam, actually we just need to consider member CD only to calculate the shear force to calculate and identify the shear force diagram, so that we can identify whether member CD has maximum moment or not. For A, B, and CD, there's no need to draw shear force diagram because we know that there's no maximum moment here. Okay, maximum moment ni normally we get whenever the beam has UDL like this, or maybe triangular load, or maybe point load. Cuma point load dia tak ada curve tu lah. Okay, just straight line, but we still can get the maximum moment by having the shear force diagram. Okay. So I think I have covers all that I need to in beam analysis using moment distribution method. Okay, ada tak question? Any question before we end this session? Do you have any question? Yeah. Ada question? Do you have any question?
No, madam. So far, so good.
Okay. So I hope it will help you to understand about all about beam analysis using moment distribution method. As I said, kalau you nak tengok by my lecture on frame, you boleh tengok juga because in CS521 MDM for this semester saya cover awal semester. So ada semualah frame-frame yang set semua ada. You boleh tengok yang tu lah. Okay, saya tak cover lah yang tu untuk your class. Tapi boleh tengok dekat my channel. So kalau direct link untuk watch the video, you boleh join Telegram my Telegram for CS521 tu. Sama je topik-topik dalam tu semua sama je boleh join sebab kat situ saya dah letak direct link. Untuk you tengok video lah sebab some video saya set unlisted so you tak boleh tengok kalau you masuk my YouTube tu you tak jumpa all lah, tapi kalau dalam Telegram tu saya letak semua link-link tu yang you boleh pilih lah mana yang you nak tengok. Okay, so that's all for this semester. Thank you very much. So I hope saya bantu you untuk understand what you should understand. Okay, if you have any question, you boleh at any time boleh tanya. If you need extra session, normally saya buat je extra session. Lepas ni before final assessment tu, your final assessment bila? Early August kan? Berapa hari bulan? 7 hari bulan ke? Your final assessment.
Ya.
7 hari bulan kan? In Penang 9 hari bulan. So nanti saya akan buat lah insyaAllah extra session, normally night session macam ni. Kalau you rasa you nak join, you boleh join. Okay, boleh tengok video-video, my video jugalah. Okay, so you boleh cari search my name lah, search my name. Link memang saya dah ada bagi dekat dalam Teams channel, you boleh tengok juga kat situ. Okay, so I wish you best of luck, good luck good luck to you all for this course. So hope you will get flying colours lah, dapat best result this semester. Okay. So thank you very much. We will meet again insyaAllah in the next session if ada session tu insyaAllah. Okay, thank you very much. Thank you for joining. Ada soalan boleh PM tepi, boleh tanya dekat Teams chat. I prefer Teams chat ya. Teams chat if you want to ask any question. Okay, sebab dekat Teams chat ni bila you message kat situ ada your full name. Okay, that's why saya prefer Teams chat. So boleh juga nak message dekat WhatsApp pun boleh. InsyaAllah saya reply je. Okay, so if you do exercise and you want me to check your exercise, so just put into your folder dekat dalam OneNote ni, your OneNote, this is OneNote, so ada semua kat sini. Okay, ada semua your name kat sini kan. Okay, you just put under mana-mana section ni, homework ke mana-mana section, you just put here and then I will check your answer. Okay, your exercise lah, you will check your exercise. Okay, so thank you very much. So mohon maaf kalau ada apa-apa kekurangan. So wish you all the best. Thank you very much. So kita jumpa lagi ya, insyaAllah. So that's all.
Thank you, Doktor.
Okay.
Thank you, Madam.
Thank you, Doctor.
Thank you,
Doctor.
Okay.
Thank you, Doktor.
Thank you, Doctor.
Thank you, Doctor.
Okay, bye.
Bye.